In our last episode, we learned the secrets behind 3D on the web. The response was incredible. We even got a like from the official Three.js team. A huge thank you to everyone who watched and supported. Today, the theory is over. It's time to write the code. We are going to take those building blocks and create this, a living creature of light swimming through a sea of lanterns. We'll be doing it all inside an editor, just like the one we're building at Anim theme. Let's begin. First, let's start with index.html, the foundation of our web page. It sets up the structure and loads our JavaScript and CSS. Doctype HTML, HTML lang en. We begin with the HTML5 declaration and set the language to English for our web page. Head, meta, charset equals UTF-8, meta name equals viewport, content equals width equals device width, comma, initial scale equals 1.0, dot, title equals ethereal fish scene dash anim theme. In the head, we use UTF-8 for universal text support. The viewport meta tag ensures our scene looks good on all devices. We give it a title, Ethereal Fish Scene dash Anim theme. Link rel style sheet href equals style.css. We link to style.css, which we'll create next to style our 3D canvas. Body. In the body, we just add a comment since our JavaScript will create the canvas for Three.js. Script type import map imports 3 https://unpackage.com/3 at 0.160.0/build/3.module.js 3/addons/ https://unpackage.com/3 at 0.160.0/examples/JSM/. This import map tells the browser where to find Three.js and its add-ons, using a CDN for version 0.160.0. It lets us use module imports in our JavaScript. Script type equals module, src equals script.js. Finally, we load script.js as a module. This will hold our 3D logic. That's our HTML done. Now let's create style.css to make our 3D canvas fill the screen and look clean. Asterisk, open bracket, margin :0, padding :0, box sizing :border box, close bracket. This is a CSS reset. We remove default margins and padding for all elements and set box sizing to border box to keep sizes consistent. HTML, body, open bracket, overflow :hidden, background $000, close bracket. For HTML and body, we hide scroll bars with overflow hidden and set a black background for a space-like look. Canvas, open bracket, display :block, close bracket, we style the Three.js canvas. Now for script.js, where we create our 3D scene. We'll set up the scene, add a glowing fish ribbon, create floating lanterns, and animate everything. We import Three.js and add-ons for camera controls and glow effects. Our import map makes these imports work. Then we create a scene, like a stage for our objects. The perspective camera has a 75-degree field of view, an aspect ratio based on the window, and near and far clipping planes. We place it 20 units back. We create a WebGL renderer that draws our scene. We enable anti-aliasing for smooth edges, set the size to the window's dimensions, adjust the pixel ratio for clarity, and add the canvas to the HTML body. To add a glow effect, we use Effect Composer. We add a render pass for normal rendering and an UnrealBloomPass for glow. We set the bloom strength to 2.5, radius to 0.5, and threshold to 0 for a dreamy look. Our fish is a ribbon made from a tube geometry. We create a smooth CatmullRomCurve3 curve with 100 points, starting as a straight line along the z-axis. The tube has a radius of 0.2 and 8 sides for smoothness.
Const colors equals open close square bracket. Const color equals new 3.color. Const head color equals new 3.color open paren 0xFFA5000. Const tail color equals new 3.color open paren 0xFF000 close paren. For loop color.lerp colors open paren head color, comma tail color, comma t. Colors.push open paren color.r, comma color.g, comma color.b close paren. TubeGeometry.set attribute open paren color, comma new 3.float32 buffer attribute open paren colors, comma 3 close paren. For a gradient effect, we create colors from orange at the head to red at the tail. We loop through the tube's vertices, interpolate the color based on position, and add it as a vertex attribute. Const tube material equals new 3.mesh basic material, open paren vertex colors, colon true. Const fish ribbon equals new 3.mesh, open paren tube geometry, comma tube material. Scene.add open paren fish ribbon. Const fish head equals new 3.vector3. We use a mesh basic material with vertex colors to show the gradient. We create a mesh for the fish, add it to the scene, and define a fish head vector to guide its movement. Const lantern count equals 400. Const lantern geometry equals new 3.box geometry, open paren 0.08, comma 0.12, comma 0.08, close paren. Const lantern material equals new 3.mesh basic material, open paren color, colon 0xFF4422, close paren. Const instanced lanterns equals new 3.InstancedMesh, open paren lantern geometry, comma lantern material, comma lantern count, close paren. Scene.add open paren instanced lanterns. We add 400 lanterns using an instanced mesh for efficiency. Each is a small box with an orange-red color added to the scene. Const dummy equals new 3.object3, for loop, dummy.position.set, open paren math.random open paren minus 0.5 close paren times 50, comma math.random open paren minus 0.5 close paren times 30, comma math.random open paren minus 0.5 close paren times 50 close paren, dummy.update matrix, instance lanterns.set matrix at open paren I, comma dummy.matrix close paren. We scatter the lanterns randomly in a 50 by 30 by 50 space, using a dummy object to set each lantern's position in the instanced mesh. Const controls equals new orbit controls, open paren camera, comma renderer.dom element, close paren, controls.enable damping equals true. Const clock equals new 3.clock. We add orbit controls for mouse-based camera rotation and zooming, with damping for smoothness. A clock tracks time for animations. Function animate, open paren request animation frame, animate, close paren, const elapsed time equals clock.get elapsed time, const delta time equals clock.get delta. Our animation loop runs at 60 frames per second using request animation frame. We track total time and time since the last frame. Fishhead.x equals math.cos, open paren elapsed time times 0.5 close paren times 10. Fishhead.y equals math.sine, open paren elapsed time times 0.7 close paren times 5. Fishhead.z equals math.sine, open paren elapsed time times 0.4 close paren times 10. We move the fish head in a wavy pattern using cos and sine for organic swimming motion. Const points equals path.points, points.shift, open paren, close paren, points.push, fishhead.clone, open paren, close paren, const new path equals new 3.CatmullRom3 open paren points, close paren. To make the ribbon follow, we remove the oldest point from the path and add the new fish head position, creating a new smooth curve. Const new positions equals new 3.TubeGeometry open paren new path, comma curve points, comma 0.2, comma 8, comma false, close paren, dot attributes dot position dot array, close paren. Fish ribbon dot geometry dot attributes dot position dot array dot set open paren new positions, close paren, fish ribbon dot geometry dot attributes dot position dot needs update, close paren. We update the tube's vertices with the new path's positions for performance and mark the geometry as needing an update. For loop, instance lanterns.getMatrix at open paren I, comma dummy.matrix, close paren, const position equals new 3.vector3.set from matrix position open paren dummy.matrix, close paren, position.y plus equals delta time times open paren 0.5 plus math.random open paren comma close paren times 0.5 close paren. If position.y is greater than 15, position.y equals minus 15, dummy.matrix.set position, open paren position close paren, instance lanterns.set matrix at open paren I, comma dummy.matrix close paren, instance lanterns.instance matrix.needs update close paren. We make lanterns float upward by increasing their y position with a random speed. If they go above 15, we reset them to minus 15 to loop. We update the instance mesh.
Controls.update and composer.render. We update the camera controls and render the scene with the glow effect. Window.outEventListener, resize. Error function, camera.aspect equals window.innerWidth divided by window.innerHeight. Camera.update projection matrix. Renderer.setSize, window.innerWidth, window.innerHeight. Composer.setSize, window.innerWidth, window.innerHeight. Renderer.setPixelRatio, math.min, window.devicePixelRatio, 2. For resizing, we update the camera's aspect ratio, projection, renderer, composer, and pixel ratio to keep the scene looking good. Animate, open paren, close paren, semicolon. We start the animation loop. Let's save and test it. Since we're using ES modules, run this through a local server like VS Code's live server or NPX HTTP server. Open index.html in your browser, and you'll see a glowing fish ribbon swimming with floating lanterns. Click and drag to rotate, scroll to zoom, it's awesome. That's our ethereal fish scene. We built an HTML file for structure, a CSS file for styling, and a JavaScript file for a glowing fish and lanterns using Three.js. You learned scenes, cameras, renderers, post-processing, and instance meshes. Try changing colors or adding more lanterns. If you liked this, leave a like, subscribe, and tell me what 3D project you want next. See you soon!